Hello again, here we are, the sixth lesson on sequences and series for year 13 pure A-level for Edexcel maths. So we've seen quite a few things so far. We've seen arithmetic sequences, arithmetic series, geometric sequences, geometric series, the sum to infinity of the geometric series, and now we're going to have a look at something called sigma notation, which is a way of writing sums of different items. As well as that, there's a very powerful Classwiz calculator function which makes these questions much easier to work out for yourself or to double check the answers in the exam. Even though the wording of the exam question, I must stress, may not allow you to just button bash in the answer. So when I'm saying these can be done with a calculator, please bear in mind I'm not asking you to just learn how to do it on a calculator. You need to understand what's going on a deeper level than that. But that said, it is nice to know how these questions can be done on a calculator in a very simple way. So let's have a look at some warm-up questions to get us in the right mood. So there's 4 to have a go at once again. So for questions 3 and 4, f of x is 3x squared plus 80 and x plus 32 for both of those questions. But try these now on your own. Press play when you're ready to see the solutions and check if you've got them correct or you may have gone slightly off. Okay, so let's have a look together first off at question number 1. So given that the point A has position vector 6i plus 5j and the point B has position vector minus 10i plus 13j, find the vector AB. What I'd suggest we do first of all is to just sketch this out on a grid. So if this is the x-axis and this is the y-axis, in other words I is going along and j goes up in the y direction, we've got 6i plus 5j. So on a grid that would mean 6 along and 5 up from this origin. So 6 along, 5 up. I'm going to put A as being here. And so the position vector of A, OA, is this line like so, whereas B has position vector minus 10i plus 13j, and so B is somewhere over the other side. It's 10 to the left and 13 up, so B is somewhere over here. So I'm going to label this as B, and the position vector of that one is minus 10, 13. So if I just label the colours of these, so that's B in that direction and A is there. Find the vector AB. Well, to go from A to B, we'd have to go from A to O, and then once we're at O, from O to B. Now from A to O is in the opposite direction of OA, so it's minus OA, then plus OB. So minus OA means negative 6i plus 5j, then plus OB means plus negative 10i plus 13j. So if we simplify this, minus 6i plus or minus is minus, so minus another 10i, that gives us minus 16i, and then minus 5j plus 13j gives us plus 8j. And we can see this, so AB is from here to there like so, and so this seems to be making sense. So from A to B we are going to the left and we're going up, so the sketch helps us to see that what we've got here is reasonable. That does make sense, and in fact I can assure you that is the correct answer to this one. Then for B it says find the magnitude of the vector from A to B, giving your answer as a simplified surd. Well, for this one we simply square the components of the I and j and square root them. So it's essentially Pythagoras, which hopefully you remember from the end of year 12. So if we calculate this now, so the square root of minus 16 squared, which is the same as positive 16 squared, plus 8 squared, we get it's 8 root 5. And so for part A, we have this, and for part B, we have this here. So let's now have a look at warm-up question 2. This question is revision of partial fractions. So we need to show that f of x, which is 4 minus 2x over 2x plus 1, x plus 1, x plus 3, can be written in partial fraction form, where a, b and c are constants to be found. So what we need to do here, first of all, is just say f of x, which is this, equals that, where we can solve it. So let, first of all, 4 over 2x all over 2x plus 1, x plus 1, x plus 3. Let that equal a over 2x plus 1 plus b over x plus 1 plus c over x plus 3, like so. So I'm going to actually give myself a bit more space here. If I put this to that side, like so, then if I multiply through both sides by 2x plus 1, x plus 1, x plus 3, in fact I'll write this down here. So multiply the left-hand side by this, and multiply the right-hand side by the same thing. And what we can say is then 4 minus 2x, because if we multiply by all of these things on the denominator, we'll just have a numerator left. So then we'll have a. Now if we multiply through everything by this thing here, the 2x plus 1 will cancel for the a. So we'll have a, then the x plus 1 and x plus 3 on the top. So it'll be a, x plus 1, x plus 3. And for b, the x plus 1 will cancel. So for b, we'll have 2x plus 1, x plus 3. And finally for c, everything but the x plus 3 will cancel. So I'll have 2x plus 1 brackets x plus 1. Now what we can do is substitute in carefully selected values of x so that some of these brackets will cancel. So for example, if I have a look at x being minus 1, if x is negative 1, this bracket and therefore all of this would cancel, as would all of this in c, because this thing with c has x plus 1 here. So if I were to sub x equals minus 1, this bracket would also become 0, so all of this product would be 0, all of this product, like I said, would be 0, so we'd just be left with the b bracket. So I could pick x being minus 1, another x I could pick would be negative 3, because anything with x plus 3 would be eliminated. And also, looking at this bracket, if I picked x as being negative a half, anything with 2x plus 1 in the bracket would disappear too. And so those are the three things I can pick for x. So in any order, in fact, I'm going to pick those values. So first of all, I'm going to say let x equal negative 1. Then what we'd have on the left would be 4 minus 2 lots of minus 1. So this would cancel here. The c stuff would cancel because that's got an x plus 1 bracket. We're just left with b. If x is negative 1, this becomes minus 2 plus 1, which is minus 1 overall. Then minus 1 plus 3 is 2. So in other words, 4 minus 2 times minus 1 is positive 2. 4 plus 2 is 6. So 6 equals minus 1 times 2 is minus 2. So we've got minus 2b. So 6 is minus 2b. And if I divide both sides by minus 2, you can see that b must be negative 3. So that's the first one I've solved. So b is negative 3. We can now substitute in, for example, x being minus 3. So if x is negative 3 next, then have 4 minus 2 brackets minus 3. The a stuff will cancel because that has an x plus 3 bracket. The b stuff will cancel as well because b has an x plus 3 bracket attached. If anything that will be left will be the c. So I'll have c, then brackets, if x is negative 3, 2 times negative 3 is minus 6, plus 1 is minus 5, and minus 3 plus 1 is minus 2. So over here, minus 2 times minus 3 is plus 6, 4 plus 6 is 10, so I have 10 equals 10c. Then dividing through by 10, I see that c must be 1 to make that work. So c is 1, then just one more to solve. So next, I can let x be negative a half. If I selected x to be negative a half, the c would cancel, the b would cancel, and I'd just be left with what a would have to be. So let's try that now. So next, let x equal minus a half. If I try that, I'm going to get 4 minus 2 lots of minus a half equals a. Minus a half plus 1 is a half. Minus a half plus 3 is positive 2 halves, which is 5 over 2. So if I neaten this up now, minus 2 times minus half is plus 1, so that gives me 1 plus 4, sorry, which is 5, don't know how I write that. So 4 plus 1 is 5. A half of 5 halves is 5 quarters, so I get 5a over 4. Therefore, if I multiply both sides by 4 and then divide through by 5, I can see that a, therefore, must be, drum roll please, a must be 4. So then we've got everything we need. We found a, b, and c, so therefore we can conclude by saying what f(x) is. So therefore, f of x equals a, which is 4 over 2x plus 1, plus b, so that's actually going to be minus 3 over x plus 1, then plus c, so plus 1 over x plus 3. So f of x can be written in this form. We've proven it by using correct substitutions, and so the question's done. So that's all that we need to do, and that's f of x. Question 3, I need to remind you what f of x is. So for this one, and for question 4, f of x equals 3x squared plus 18x plus 32. Now for part A, we need to write this in the form a brackets x plus b all squared plus c, where a, b and c are integers to be found. This can be done largely on the Classwiz. I'm going to show you how to do it manually. In effect, all it's asking you to do here is to complete the square. I'll show you how this can be done on a Classwiz. So, without the Classwiz first, to complete the square we have to factorise out anything before the x squared term. So we need to factorise out this 3 first of all. So I've got x squared there. Factorise out the 3 from the 18x, that gives me 6x. Now this 32 can be left on its own, that's fine. At this stage now we complete the square on what's inside these big squared brackets. So instead of x squared we put the x in, we halve the coefficient of the x term, so half of positive 6 is positive 3. We square all of that and then subtract away what this term is squared. So plus 3 multiplied by plus 3 is 9. So we subtract off 9. Finally, we need to remember to have that 32 on the end. Now we can expand out. So we've got 3 lots of x plus 3 squared. 3 times minus 9 is minus 27. And of course that plus 32 is still hanging on there at the end. Finally, just simplify the values. So 3 lots of x plus 3 squared. And 32 subtract 27 leaves us with plus 5. So that's what we need it in the right form. So in our case, A is 3, B is 3, 2, and C is 5. It doesn't ask us to stay A, B, and C, but we've got it in the right form, so that'll do. Like I said, how can this be done on a Classwiz? Well, the first thing we need to know is whatever number, whatever value we have in front of the x squared, that number will always appear here. The Classwiz won't tell you that, but because that's a 3, we have a 3 there. If that were a 10, that would be a 10. So that's just something we need to remember. The Classwiz, though, will essentially tell you these two values here, the plus 3 and the plus 5. And I'll show you how it does that. So what we do is we go to the Classwiz. Whoops, just get this to the other side. Okay, we then press Menu, and we scroll along to option A. Equation / function. Press equals. Now, a quadratic is a polynomial, so press 2. And because the highest power of x is squared, we want degree 2. I need to remember that when we complete the square, it tells us the turning point. It tells us the maximum or minimum, depending on how we're looking at things. So here, what we're doing is we're going to complete the square, and because now we know what the minimum point is, the minimum would be when x is minus 3, then y would just be 5. So you need to bear in mind what completing the square tells you to understand that the calculator is essentially telling you the same thing in a different way. Anyway, so we type the numbers in as f of x appears. So it's 3x squared, 18x, and then 32. Press equals and equals again. Here, we're not actually interested in the solutions. Press equals again for the second solution. We're not interested. But press for a third time. The minimum value of x is when x is negative 3. This value here is the same as what you need in your completed square form, the same number with the sign switched. So for minus 3, we write plus 3. If that were, say, plus 2, we'd write minus 2 here. Press for the fourth time, we get this constant term at the end, which is exactly what the calculator says it is. So press equals again, we have 5. So that 5 will match there. The x-coordinate of the minimum will be the same as in the brackets, but switched. As long as you remember that, and that the coefficient of the x squared here pops there, the calculator does the legwork for you. So that's worth bearing in mind. Part B. So from part A, we know where the minimum point is on this. So I'll just put in brackets. The minimum point is when x is minus 3 and y is 5. So the minimum value of y is positive. It's 5 when x is minus 3. If that's the minimum value of y, that's essentially saying it's never going to cross the x-axis. Whoops, that's a terrible sketch. So it's going to be something like this. And the y-coordinate, where it crosses the y-axis, for y-axis intercept, we can just sub in when x is 0. When x is 0, nothing plus 32. So the y-intercept is 32. Finally, question 4. Question 4, describe a transformation which maps f of x onto g of x. So just to remind you again what f of x is. F of x is 3x squared plus 18x plus 32. Now we've got here g of x. It looks a bit similar, but the x here has been switched with x minus 2. So the trick here, we're going to try what f of x minus 2 looks like and compare it to this. And if it's different, we can work out the difference and then compensate accordingly. But we're trying to get this in terms of f of x. So this clue here is to just use x minus 2 as our input. So what would that give us? What's f of x minus 2? Well, all we're doing here is we're switching any instance of x with now x minus 2. So instead of 3 lots of x squared, we're going to have 3 lots of x minus 2 squared. Instead of 18 lots of x, we're going to have 18 lots of x minus 2, and then we add 32. So let's see what happens there. So if we do this now and try and simplify it, leaving the 3 lots of x minus 2 there, of course, so 18 times x is 18x. 18 times minus 2 is minus 36. Then still got the plus 32. So 3 lots of x minus 2 squared. I then have plus 18x. 32 minus 36 gives me minus 4. So compare this here. That's f of x minus 2. Compare this to that. Almost exactly the same. 3 lots of x minus 2 squared, I've got that. I've got the 18x. But the minus 4 has increased to plus 10. So it's this here is f of x minus 2 plus an extra 14. So therefore g of x is what f of x minus 2 is, plus an extra 14, like so. This is a compound transformation. It's a couple of different things happening. So, like with BIDMAS in a way, we need to focus on the brackets first, then this number after at the end. So, therefore, we can say gx is fx moved somehow. So like I say, focus on the brackets. I always teach it in terms of inside, opposite. So if there's a change on the inside of the brackets, it works in the opposite to expected way. So here it looks like we're subtracting 2 from the x-coordinates. Actually, f of x minus 2 is a shift of 2 to the right. So we're shifting f of x 2 to the right, and then we're adding 14. So going to the right by 2, then up in the y direction, 14 units. So in the simplest English I can explain, g of x is f of x moved 2 along and 14 up. So g of x is f of x moved by a translation vector. So gx is f of x translated by vector. Like I say, 2 to the right, 14 up. So top number's 2, bottom number is 14. And finally here, find the range of a function h of x equals 15 over 3x squared plus 18x plus 32, where x is any real number. So I'll just mention we've done A here. Now B is this. We need to notice h of x is 15 divided by what's on the bottom is actually f of x. So the range of h of x will be based on the range of f of x because h of x itself is based on this function f of x. So just thinking of b here, just requires a bit more thought. So let's think about for f of x. Well, from part A of question 3, we completed the square for f of x and worked out what its minimum value was. So the minimum value was actually when x was negative 3. So the minimum value was when x was negative 3. And that was when we got y was 5. It was fx equaled 5 when x was at negative 3. So that's what we can base this on next. So we've got f of x. Obviously the minimum is 5. And that minimum occurs, like we've said, when x is negative 3. So we can fill in that the minimum is 5. And the maximum, well, for f of x, because it's a quadratic, as x goes towards infinity, x squared is going to go towards infinity as well. So it's unbounded at this end. So it can take values as low as 5 up to whatever. So that's f of x. Now, if we compare this to h of x, which is 15 over f of x, first of all what I'm going to do is think about 1 over f of x. We're going to build it so it's the same as h of x, so we can find the range of h of x instead. The minimum value of f of x will correspond to the maximum value of 1 over f of x. If the smallest f of x can be as 5, then the biggest thing that 1 over f of x can be is going to be 1 over 5. And similarly, if the largest thing is unbounded towards infinity, then the smallest thing 1 over f of x can be is going to be 1 over something near enough infinite, which is going to be 0. So essentially 5 goes to 1 over 5, infinity goes to 1 over infinity when we're talking about 1 over f of x. But h of x is 15 lots of 1 over f of x. So if I multiply all by 15 here, I'll get to where we need to be. So 0 multiplied by 15 is obviously 0. 1 over f of x times 15 is 15 over f of x. And 1/5 times 15 gives us 3. So from this we can hopefully see that therefore the range of h of x where h of x is of course 15 over f of x, which is what we've got here, it's between 0 and 3. So we just fill this in and we're done. So between 0, non-inclusive, all the way up to and including 3. So that's the warm-up done. So now we can think about the main bit of this lesson using sigma notation. So, sigma notation. Very brief and we'll get straight into it. The Greek capital letter sigma is used to signify a summation. Sounds a bit like what you're wanting to do. Sigma, sig, sum. Well, not quite, but begins with S anyway. So let us now see how we use sigma in an example. So, evaluate the sum. This means from r being 1 up to r being 5, we want to sum 5r plus 1. So what I'm going to suggest we do from first principles is to write this out the long way. Okay, so what I'm going to do here is suggest we do it in this long form first. So the sum of, from r being 1 up to 5, of 5r plus 1 is going to be when r is 1, so 5 lots of 1 plus 1, and then the next one is going to be 5 lots of 2 plus 1, that's when r is 2, then it's going to be 5 lots of 3 plus 1 plus 5 lots of 4 plus 1, and finally 5 lots of 5 plus 1. Do we need to do this for every single question? You might be thinking, well, no we don't. We absolutely don't. So this is just to make a point that these are where the numbers I'm going to discuss have actually come from. So 5 lots of 1 plus 1 is 6. 5 lots of 2 plus 1 is 11. And it's 16, 21. And this one here is 26. And so all of this here is just neatly expressed by this thing here. This thing of highlighted in yellow is this summation. It's one and the same thing. But we can now link it back to what we already knew. So the first term, you can see, A is 6. That's what happens when we sub in R being the first value down here. So when R is 1, 5 times 1 plus 1 gives us 6. The common difference links to this 5. As you can see, the numbers are going up in 5s. So the common difference here is 5. And of course you can see it's arithmetic. The differences are the same each time. So for some of this one, now obviously you could just add up these numbers if you want to. In fact, I'll do that as well with you. For some of this, from 5r plus 1, where r goes from being 1 up to 5, we can think about this in terms of a arithmetic sequence. So the sum of an arithmetic sequence is n over 2, in other words, the number of terms, and here the number of terms is 5, so it's 5 over 2, brackets, 2 lots of the first term, so 2 lots of 6, plus a number of terms subtract 1, so 5 minus 1, multiplied by the common difference, which of course the common difference is 5. So if we simplify this, so 5 over 2 is 2.5, 2 times 6 is 12, and then 5 minus 1 is 4, 4 times 5 is 20. So it's 2.5 multiplied by 32, which of course we could do fairly easily if you wanted to using the calculator. That would give us 80 if you wanted to try it. Or you could do this sum in the long way. So if we just add up all these together, so 6 plus 11 plus 16 plus 21 plus 26, that does indeed give us 80. And as well, the calculator very conveniently has a sigma notation built into it. If we press Shift, then the X, instead of R, we use X on the calculator. So X goes from 1 to 5, because R goes from 1 to 5, where we type in 5 lots of X, in our case, plus 1, press equals, and you'll see, again, we get 80. So to answer some questions you might be thinking, do we need to do this for every single summation we see using sigma notation? No, you don't. If a question is worded in a very loose way, where you're allowed to use a calculator, you probably aren't. The question might be worded show algebraically or use clear reasoning. But if you could get away with using a calculator, that's one method, albeit quite unlikely. The best thing to do is to write down the first 2 or 3 terms. By understanding what the sigma notation means, write down the first few terms to get a feel for what sort of sequence it is, whether it be arithmetic or geometric. In this case it was arithmetic, so work out what A and D is. If it were geometric, work out what A and the common ratio would be. And for harder sequences in sigma notation, I'll give you a few pointers for those in these upcoming worked examples. Two important results though. Pardon me. If you sum together from r being 1 up to n of just 1, this means 1 plus 1 plus 1 n times. So this just gives you n. The sum of one unit, n times, is just 1 times n, which is n. Trivial result, but worth knowing. And this one here is the sum of the first n integers written in sigma notation. So if you add up all the integers from r being 1 up to n, 1 plus 2 plus 3 all the way to n, this is the result we mentioned in the very first lesson. The sum of the first n whole numbers is a half n multiplied by n plus 1. So those results are worth noting down, committing to memory, because we're going to use them going forward. So let's try a couple of worked examples. So for 1a, evaluate the sum. So like I said, work out the first few in the series. So r equals 1 up to 20 of 6r minus 9. When r is 1, we can have 6 times 1 minus 9, which is minus 3. When r is 2, 6 times 2 is 12. 12 minus 9 is 3, and so on. Do one more. When r is 2, sorry, when r is 3, I mean to say, 6 times 3 is 18. Take away 9 gives us 9. So I'm hoping you can see here, this is going to be an arithmetic series with common difference 6. The first term, a, is minus 3. The common difference is 6. Therefore, the sum of the first 20 terms, if I was going from 1 to 20, it's the sum of the first 20 terms. So it's half n, so it's 20 over 2. 2 lots of the first term, so 2 times minus 3, plus the number of terms, 20 minus 1, multiplied by the common difference, which in our case is 6. So we can have 10 multiplied by minus 6 plus whatever 19 multiplied by 6 is. So if we just do this on the calculator, so 10, then brackets, minus 6 plus 19 lots of 6, that gives us 1080. So 1080. And part B is actually fairly simple, fairly similar, I should say. So for B, similar idea, but you notice here, this is R where R is in a power relationship. So this is likely going to be geometric, but what we're going to do, we're going to test it. So what would the first few terms be? If I went from R being 1 up to 11, 3 times 2 to the power r minus 1. Well, when r is 1, we're going to have 2 to the power 1 minus 1, which is 0. 2 to the power 0 is 1. So 3 times 1 just gives us 3. When r is 2, the power here on the 2 is going to be 2 minus 1, which is 1. It's just going to be 2 to the power of 1. 3 times 2 to the 1, that's just going to give us 6. Try it this way as well on a calculator. If you don't like what I'm doing here, just literally type it in and substitute in on the calculator what you want r to be. So the next one would be the third term, when r is 3. So do 3 times 2 to the power of 3 minus 1. You can see it's 12. Do more terms if you want to. The main thing is you should see that the common ratio is 2. The multiplicative factor going from one number to the next is 2. The numbers are doubling. So here, the first term is 3. Common ratio is 2. And the sum of the first 11 terms is going to be the first term a, then we're going to multiply that by the ratio to the power of n, so 2 to the power 11, because talking 11 terms, minus 1, all over r minus 1, which is 2 minus 1. So again, if we just carefully type this into the calculator, see what we get, double check it, if necessary, 3 brackets, 2 to the 11 minus 1, all over 2 minus 1, which will just be 1 on the denominator anyway. We get 6141. Now I did say, can this be checked on the calculator? And of course it can. So if you just remember those numbers, 1080 and 6141, I'm going to show you how you could just check this very easily using the Classwiz. So just double checking those figures. So for this one we got 1080. This one over here was 6141. So using the Classwiz, press Shift X. Type X goes from 1 to 20 for this first one. Then instead of 6r plus 9, we type in 6x, sorry, minus 9. We get 1080, so that sorts that one out. Whereas this one here, we want to go from r being 1 up to 11. And this time, we type in 3 multiplied 2 to the power of x minus 1. Once again, you see we get the same answer as what we got before, which is just 6141. Let's have a look at a second worked example. So now we need to evaluate these summations. So again, I'll do A and B separately. Don't panic about B, that looks impossible, but I'll give you a little hack for this one. For A as well, that might freak you out because you're not starting from 1. But you know what? Don't worry about it. Start from where you need to start. So if I start from R being 8 and go up to 14, then what I'd have, first of all, when R is 8, I'd have 3 times 2 to the power 8 minus 1, which should be to the power 7. So the first term is 3 times 2 to the 7. Next one will be 3 times 2 to the 8. Then 3 times 2 to the 9. I should technically put in plus symbols here actually. This isn't a sequence, it's a series. Slight difference, but very important, so I should be technically accurate here. So plus, plus, then keep on adding all the way up to and including the last one when R is 14. That'll give us 14 minus 1, the power of 2 will be 13. Now be very, very careful how many terms this is. A common mistake would be to think, well, this is 6 terms, isn't it, Mr. Bailey? Because 14 take away 8 is 6. But actually, no. Your first term is that one, 2 to the 7. Second term, 2 to the 8. Third term, 2 to the 9. The fourth term, 2 to the 10. Fifth term, 2 to the 11. Sixth term, 2 to the 12. This is actually the 7th term. If you count the powers starting from R being 7 up to 13, or if you just count R from 8 up to 14, think about counting from 8 to 14. You've got 8, 9, 10, 11, 12, 13, 14. So think about it as fence posts. You might have only one fence, but you need 2 posts. This is often called a fence posting problem. So this one, you need to add an extra 1 on, because we're going from 8 to 14 inclusive. But now we've got that out of the way, the actual process now isn't so bad. It's a geometric series. So the first term, A, we know that's 3 times 2 to the 7. And each time the term goes up by 1, the next term along is always times 2 again. The power of 2 is increasing by 1 each time, so the common ratio is 2. The terms are doubling as we move along. So this one here, we've got 7 terms to sum. So the sum of these 7 terms is the first term, a, 3 times 2 to the 7, times the common ratio, which is 2, to the power of the number of terms, in our case it's 7, again minus 1, all over r minus 1, which is 2 minus 1, and again, the denominator is just 1, so we're just working out the numerator, essentially. So let's try this one now, and see what we get. So we're going to have 3 times 2 to the 7 on the top, and brackets 2 to the 7, subtract 1, all over 2 minus 1. May as well just write it as I've written it in real life, why not? I get this, I get 48,768. Now part B, you need to be particularly careful of part B, but as long as you're careful, this is absolutely no problem, because summations can actually be partitioned. Okay, so they can be partitioned in whichever way you're comfortable doing so. So what I'm going to suggest we do first off for these ones is partition each term separately. So for B, from r being 1 up to 10, 3 plus 2r minus 10 to the r, this can be partitioned out in terms of that number plus that one, all under the same sigma. So the same as r being from 1 up to 10 of 3, plus the sum from r being 1 up to 10 of what 2 to the power r is, then minus 10 to the r, I'm going to put here minus the sum from r being 1 up to 10 of 10r. So these can now be partitioned further. So any constant can be factorised outside and before the sigma symbol. So this 3 is a constant, so I can factorise out 3 and leave just a 1 there. Nothing to factorise out here, so I'll leave this one as it is. That's just 2 to the r. And here I'm going to factorise out the minus 10. And just sum r from r being 1 through to 10. Now here we need to remember those important results from before. So for this one, we said that the sum of the first n instances of a unit just gives us n. Okay, so we can use that result. So because it's 3 lots of that, it's going to be 3 times n, so it's going to be 3 times 10 for this first one. So 3 times 10. Next along, we've got 2 to the r. So again, thinking of this on its own. If we're summing 2 to the r, from r being 1 up to 10, the first value will just be 2 to the 1, which is 2, then 4, then it'll be 8, 16, and so on. So the first term, a, is 2, common ratio is 2. So the sum of the first 10 terms here is the first term, which is 2, and brackets, the common ratio to the power of how many terms are adding, which is 10, so it's going to be 2 to the 10 minus 1 all over 2 minus 1. So I can write this in here, so 2 lots, 2 to the 10 minus 1 all over 2 minus 1. And the final one, at the end, this minus 10, the sum of r from being 1 to 10, this is minus 10 lots of the sum of the first 10 integers, which again was a result we discussed in the introduction to sigma notation. So for this one here, we can use this following result. So the result being, if we sum r from r being 1 up to say n, this gives us a half n brackets n plus 1. So in this case here, we're going to have minus 10 multiplied by a half n. Well, n here is 10. So a half of n, a half of 10 is 5. Then n plus 1 means 10 plus 1, which is 11. So in fact, I'll do a different colour for that one. I'll put this colour down as a light blue. If I can. There we go. And then that matches. So that matches to that. It's not quite the same colour, but never mind. So this here is going to be 5 times 11. So if we just type this into the calculator and see what we get, that will be our final summation. So just be careful as you type it in. So we're going to have 3 times 10 plus, then brackets 2 to the power 10 minus 1 all over 2 minus 1. Then minus 10 times 5 times 11. And that's going to give us 1526. So again, how to check these on a calculator. Now, by the way, part B, you wouldn't have needed to have partitioned out like this either. So for part B, an alternative for part B, you could have split it into just 2. So from r being 1 up to 10, could have done 3 minus 10 to the r. That would have made you a arithmetic series to work out. Then you could have just done from r being 1 to 10, 2 to the r. So you could have worked this out as a arithmetic series to sum, and this is a geometric one. And you would have got the same result as well, 1526. Again, just quickly, I'll show you how to check these on a Classwiz. So the numbers we're trying to check from last time are 48768, and over here 1526, I think it was. Yeah, 1526. So first of all, this one, to check the first one. So we're going to press Shift X, going to sum it from 8 being up to 14, and what we're summing is 3 multiplied by 2 to the power of x minus 1, and we get 48768 like we needed. And for part B, what we're trying to work out here is this beast. So again, Shift X, sum it from 1 up to 10 of 3 plus 2 to the power x minus 10x. And again, we get 1526 as we see here. So that's a very quick way the Classwiz can be employed to just double check our working out. Let's now have a look at the final worked example. So here we are, last but not least, final example. So given that the sum from r being 1 up to k of 6r minus 5 is 6,816, we have to show that k satisfies 3k squared minus 2k minus 6816 equals 0. Then part B, we need to find that particular value of k. So first of all, let's just think about what this means. So from 6r minus 5, r being 1 up to k, it's going to be a sum of a arithmetic series. So first of all, get the first few terms. So when r is 1, we're going to have 6 lots of 1, not plus, sorry, minus 5. What am I talking about? So that's going to be the first term. The second term is going to be 6 times 2 minus 5. The third term will be 6 times 3 minus 5, and so on, and so on, and so on. So let's just work out now what these terms would be. So 6 times 1 minus 5 is 1. 6 times 2 is 12, minus 5 is 7. 6 times 3 is 18. 18 minus 5 gives us 13. So here we can see what the first term is and the common difference. So for A, we know that A is 1, and the common difference D equals 6. So the sum of the first k terms is the number of terms divided by 2. So in our case, it's going to be k over 2. And then we're going to have 2 lots of the first term, so 2 times 1, plus the number of terms minus 1, number of terms is k, so that's k minus 1, multiplied by the common difference, which is 6. And we're told that that sum of the first k terms is here. We're told that that is 6,816. Don't expect it to change like that, the pen. So 6816. So I'm going to keep the over 2 on this side. I'm not going to multiply by 2 yet. So k over 2. 2 times 1 is 2. K times 6 is 6k. Minus 1 times 6 is minus 6. Again, leaving things as they are, so k over 2, I've got 6k. 2 minus 6 is minus 4. That equals 6,816. Now I can expand it out. So k times 6k is 6k squared, but I'm halving that, so it's 3k squared. K times minus 4 is minus 4k, but because it's over 2, minus 4k divided by 2 is minus 2k. And that equals that 6,816, which we mentioned before. Finally, subtract 6,816 from both sides. We see, therefore, that 3k squared minus 2k minus 6,816 does equal 0 as required. Now, these days, with a Classwiz, this is an absolute piece of cake, part B, because now we can just bang this in using the quadratic function formula, which is inbuilt to the Classwiz, and it'll drop out for us what k has to be. Factorising this, old school, would be quite tricky. So, using the Classwiz, we can work out what k is. So just to remind you, what we're going to do is type menu, scroll to option A, press equals, press 2 for polynomial, degree 2 because it's a quadratic. We've got 3k squared, so type in 3, then minus 2 because we've got minus 2k's, and finally the constant is minus 6816. Press equals and equals again. So the first value here is 48, sounds reasonable. it's quadratic, so I might have two different solutions, but if you were to press again, we can't have a negative term number in a sequence, and certainly can't have it where it's a decimal or fraction. So this is a nonsense on both counts, so we reject this solution and therefore conclude that k must be 48 only. The 48th term would give that sum as we need. So yet again, I'll show you how to check this on a Classwiz. So checking on the Classwiz that k being 48 will work, we just type in this sigma summation with 48 in place of k. So next up, all we need to do here is just type in Shift X, be back in normal mode, so Shift X. So I want this to be from 1 up to 48, 6r minus 5, we type in as 6x minus 5. Keep skipping past it. There it was. Apologies. 6x minus 5. Does 48 work? Does it give us 6816? Yes, it does. Big relief. We've checked our answer. It works. Thank you, examiner. Put some marks in my account. And there we have it. That's all of that from me. It's now over to you to try some on your own. Page 77, exercise 3F, 1, 2, 3, 10, 11, 12. Try them all. You know the drill by now. Check the questions regularly as you go. Ask a neighbour if you're unsure. Ask me in class if you're still unsure or stuck. If you can't reach me, please drop me an email, or you can even leave me a comment in the section of a video. Thank you for listening. Please like and subscribe, and you'll see me around the office or my classroom very soon indeed, if not online. So take care. I'll see you soon, I should hope.